Hello everybody, this is Mr. Lakin. I'm doing a video on graphing calculators and how you can use them on the AP test to be successful when derivatives are concerned. And then I'll probably make another video on how we do this with integrals because that will be another new function on the calculator that we'll use at that time. The AB Calculus exam requires you to use a calculator for 15 multiple choice questions, but not all of those multiple choice questions will actually require a calculator. Many of them are just looking at graphs and analyzing them, or looking at tables and analyzing them. But there are very specific problems where you must use a calculator, or else you will be there all day and all night trying to get the answer. There are also two free response calculator questions. The purpose of this video is to make sure that you are familiarizing yourself with how to actually use the calculator in an efficient way to solve the calculus problems that are incorporating derivative concepts. The derivative concepts that are incorporated here are going to be derivative values and slopes of tangent lines, as well as graphing derivatives, local extrema, and increasing, decreasing, concave up, and concave down. This video is particularly, we'll go over 3 AP questions that are multiple choice questions, as well as one problem, one function that I made up, but multiple problems for that function that I made up, but I know are popular questions asked in the AP exam. For the questions, for any of the questions, not just for the 3, for any of the questions, take notes on how to use a calculator. I will talk about it, but you'll want to write down your own tips for it. The accompanying video will only provide tips for the most popular calculators, which are TI-84 Plus or TI-83 Plus. If you have a TI-89, Inspire, or Casio, just let one of us know, and we can help you figure out how to solve the calculus problem with your specific calculator. The calculator that I have and that I use is the TI-84. I think I have the silver edition, and I had to upgrade the OS on it. So I'm just going to make a note here. Actually, I'll do that on the next page. If you were to go to your calculator, this is the best test, and you're going to go to Math and 8, you either get this screen, which is on the left, or you get this screen on the right. If you get the one on the left, you can just start typing your function and your value, and you can get your derivative for what you need. If you get the one on the right, though, it will give you an empty parenthesis here, and then you have to actually start typing something in. And the order that you need to type things in are going to be function, and then x, always x, and then x value, whatever x value you want. So if we were to do f prime of 4 for, let's say, cosine of x, f of x is equal cosine of x, you will need to type in, again, it would be n derive, which is math 8, and then you would do cosine x, and then you would have to do comma, x, then another comma, and then 4, and enter, and you would have it. In this calculator, the calculator would have already given you this part, which is d dx, and they just want to know what the derivative of. You would put in cosine of x and close the parentheses, and then it gave you this line, and it's telling you that they want to know what to evaluate it at, and you would say at x equals 4. So these are the two differences in how you would enter derivatives on two different types of calculators. I can tell you that the TI-84 Plus, let me just jot some stuff here. The TI-84 Plus, hold on just a second, let me get a different color here. Size font, TI-84 Plus, new operating system, and TI Inspire will give this type of format. If you have a TI-83 Plus, you will always have to type it in that format. If you have a TI-84 Plus and you're still getting the screen on the right, that means you need to upgrade your operating system. And you can do that online if you have the cable, and if not, if you're ever in school and your teacher is ever in school, your math teacher is ever in school, or any math teacher is ever in school, then you can actually go there, go to the math office, and we can get you a new operating system. It takes about a couple minutes total. All you need, we have the cables, and you just need to calculate the new operating system, then we can update you. Please note also that if you have the TI-89, you'll also have to type in this format. The TI-89 is a very powerful calculator, more powerful than the TI-84 Plus, but it's a little bit older display. So TI-89, always have to type in format as well. So now let's get to our problems. Now that we're 5 minutes into the video, we have a function which is sine of a whole mess. It's a hot mess here. And what we need is we need f prime of 0.05. We need f prime of 0.05. I'm going to get those for you in different methods. We need a horizontal tangents wherever x exists, where f has horizontal tangents. We need to write an equation of a tangent line at x equals, this should actually say 0.03. We'll do 0.05 actually. So we'll do all of that here. I have a spot on the bottom that has some bonus tips. So anything that I'm writing, anything that I'm saying, feel free to jot down. That might be a good tip for you to know. So let's go ahead and do f prime of 0.05. First of all, let's go and enter our equation in the calculator. Now I already typed mine in. We have, whoa, I thought I typed mine in. Let's try that again. We have y equals sine of parentheses and then the root. This was if I had one of the newer calculators, like an 84 Plus or an Inspire. That's how that format would look. If you have an older format, just make sure you're putting parentheses around your numerator and your denominator. You might be saying, well, Mr. Lakin, I tried typing this in, but I wasn't able to get the bar to look like this. Well, this is my first tip to you. If you go to, and I'm just going to put this in y5 and delete it in a second. If you go to alpha and y equals and select number 1, you actually can get that fraction bar there. So the way I typed in y1 is I did sine and I open up parentheses. Sorry, it opened up automatically, so let me try that again. Sine, parentheses are opened up. I'm going to do a root first. And then I'm going to do alpha and y equals, and number 1. It will put that root, the fraction in the root automatically. So if you have one of the newer calculators, you're welcome to do that. Again, alpha and y equals gets me a fraction bar. And every time I show students that, they're just like, what? Oh my gosh. Okay, next. So what we did is we entered this information into y1. You only need to enter one equation, and you did not have to enter two equations. I was just putting this here for people to see. Let's go to the main page, second mode. And again, we're looking for f prime of 0.05. If you were to get a 0.05 on the AP exam, let's see what happens here. I'm just kidding. Math 8. Math 8 will be the derivative. And what I'm going to do is I'm going to type in an x here for the newer calculators. Here's another good tip to know. Since I already put that function of y equals, I don't really want to retype it. So I'm going to do alpha trace. Alpha trace is y1. And then I'm going to do x equals, and I'm just going to type in that value of 0.05, and I'm going to see what the slope is. Okay, and the slope is about 0.111. Please note we only use 3 decimal places in this class, and that's all the AP requires as well, 3 decimal places. One thing I also didn't note is that our mode in calculus will always be in radians. If you're in physics, you're going to have to be cognizant of going back and forth between the two forms of degrees and radians. We always use radians in this class. So this is what your answer would look like if you had the newer calculator. If you had the old calculator, the 83 Plus or an old operating system, it would be the same thing and derive. You would type in y1, but to get y1, you need a little bit of a different step. You're going to find, and I'll show you on this again, because this works on both calculators. You get math 8. We'll type in the x again, but for y1, you can go vars, yvars, function, and then that gets you to your y1 menu. Obviously, alpha trace is a lot easier than that, but if you have a TI-83 Plus, alpha trace and alpha y equals does not work on your calculator. So just to let you know, this alpha trace and alpha y equals only works on the newer operating systems. But I'll write that in as a nice tip, alpha trace. If you're thinking, wait, it really sounds like Mr. Lakin is saying that I should just get a new calculator. If you have the means, I would recommend it because it's a much easier calculator to use, and you don't have to remember all the syntax on top of all the other calculus stuff you need to know and apply. This gets you to y1 or y2 or etc. Okay, but again, these two only work on new operating systems only. So something like the TI-84 Plus or the TI Nspire. And again, if you have any of those other calculators, we can help you out with that still. Okay, so we found f prime of 0.05 on the home screen. Let's see how we can do it on the graph. To do this on the graph, we could do one of the following ways. Let me clear that. Let's go back to y equals. I'm going to, again, I have y3 deselected here. I'm actually going to clear it out so that way no one tries to do this on their own and get errors. What I'm going to do, anytime I have a trig function, I always do a zoom trig. So that might be a tip you want to write down. Not really though, if you're not into that. And what I can do from the graph screen now is go to second trace, which is the calculator menu. And I'm going to go to number 6, dy dx. And dy dx, what it asks for is it says, okay, now give me an x value you want the derivative of. And I can type in 0.05, push enter, and there's my derivative value, 0.55. I'm sorry, 0.111. So notice I have 0.111 here, and also nicely gives me the y value. So in fact, I actually like this one a lot, this derivative value a lot, because when I do that, this gives me not only the derivative value, so it gives derivative value, but it also gives me the x and the y value. And why would I care about the x and y value? Because when I have to write an equation of a tangent line, now I have all that information. I have f of 0.05, and that looks like it was about 0.551. So now I can just go y equals, and then again, the slope was 0.111, x minus 0.05 plus 0.551. So the graph actually makes it very easy to get an equation of a tangent line. So note that, please. A second way that you could get the derivative here, and then I'll go back to this one in just a minute, to get a graph of this using a second method, we can actually graph the derivative if we wanted to. The way you would do that is you would deselect y1. You're keeping it there, but you're deselecting it. The way you deselect is go to the equal sign and push enter. Go to y2, do a math, an 8 for nderive, type in ddx. Let's put y1, that was alpha trace y1. And then where x equals, let's do x equals x. And what the calculator is going to do is it's going to plot every single x value's derivative on the graph. And that's going to be cool. So let's go ahead and do ddx of y1, x equals x. Now, when you push enter, you're going to notice that the calculator takes a longer time to load. And there's a reason for that. The reason that it takes such a long time for the calculator to load is because it is trying to do all that math to find the slope for every single point of your function and then plot it on the derivative graph. So let's have some patience here, guys. So the thing that I did for the second method was, again, I did the derivative in y2 of y1. Notice it graphs the derivative without actually giving what the function is, because I don't really care what the function is. And to get that value, again, going to second and trace, I can select number 1, which is the value, and I can type in 0.05, and I will get, again, that 0.111. So that's going to be the value on the graph's derivative. Okay, so there were a few different methods there. This was used y equals, and this one used second and trace. And that got me the calculator menu, and I could get the actual value. For the first one, just to summarize here, I used y1, which was alpha trace, and I opened up parentheses and plugged in a number. Actually, I don't, no, I did. I'm confusing myself because I made 2 versions of this video already. Let me try that again. What we did, and I'll just show you just to make sure we're clear, I did math 8 and then put in y1. So math and 8, and then typed in y1, and again, y1 was alpha trace. I opened up, I didn't open up in parentheses, I don't have to do that on this y1, and then I did x is equal to the number 0.05. Okay, so those are the three different ways that you can actually evaluate a derivative. Each one has its own advantages, and what I would recommend in this next unit is using your calculator a lot to try to make sure you're familiar with these ideas. And try to balance making sure you know how to do the actual derivatives, because there are many derivatives you have to do without a calculator. So it's kind of a balancing act. For the next part, find x such that f of x is horizontal tangents. Let's skip this for right now, and we'll come back to this. And we will go ahead and do, so we'll come back to that in just a second, write an equation of a tangent line. I showed you that if we did the first method here, we can actually come up with it very easily. If we do the second, if we do it from the home screen, what we would have to do, this line, the first line got me the slope of the function. And then what I could do is I could do alpha trace y1. The reason I'm doing this is to actually get the y value on the main screen, y1 of 0.05. So I can open up parentheses like this, and this is the calculator's way of saying, oh wait, I have a function in y1, and I'm taking an x value, and when I push enter, I'm going to give you the y value. So here was the y value of 0.551, and this is how I would have done this on the home screen. So I will leave it at that for different ways of how you could write the equation of a tangent line. This box should actually be open, and it is on your sheet. You would do again, let me just clear this off and make this a little bit neater and readable. If you want to see that information, you could rewind the video. To write an equation, you would do again math 8. That would get you ddx of y1 evaluated at x equals 0.05, or you could get not or, so that would be step 1. Sorry, I'm thinking of a couple things at once. And then the second step you would have to do is actually do y1, because you need the y value at that function, and then enter your 0.05, and again that would get your y coordinate. So this number 2 is your y coordinate for your equation of the tangent line, and number 1 is your slope for your equation of the tangent line. The second way you could have done this, just to recap again, is by going to y equals, enter your function, and then graphing your derivative. I'm sorry, and then going to graph, and then doing a second and trace. That brings your calculator menu, and select dy dx. Then enter value. And that gives you all your information in one screen, but with a few more button pushes. Okay, next, to find x such that f of x is horizontal tangent. So this is again a popular problem that's asked. There's no way to find the horizontal tangents on the home screen that I know of. So what I would do actually is on y equals, I'm going to keep this one here first. I'm going to keep the derivative graph here first, since we have it already. So number 1, I could have my derivative graph here. Have ddx and y equals menu. Then go to the graph, and we'll just find roots. Because anywhere there's a root on a derivative graph is anywhere the original function has horizontal tangents. So again, what I'm saying here is anywhere the dy dx equals 0 is where f of x has horizontal tangents. Okay, so what I could do here is when I go find some roots here, it looks like I have a root here and there, so I'm going to go and do second and trace. This is a pre-calc skill that I expect you to know. This is a 0 here, so number 2. And I'll just pick two values around this one, like -3 and -1 for my left bound and right bound. 3, enter, and -1, enter, and enter. And yep, right in there. It looks like I have one root at -2.956. So negative 2.956 would get me this one. Would be the first x value where I have a horizontal tangent. And then I could repeat this for that second part. When you're asked to find a horizontal tangent, you can use your derivative graph and then go to that graph and find the roots of that derivative graph. That will be where f of x is horizontal tangents. Other way you could do this is find you cannot actually you can. Okay, so let me go ahead and deselect y2 now. Let me go back to y1 and select that. And the way you can find horizontal tangents on the actual graph is by going to anywhere that it looks like there's a max or a min, any change in direction. So it looks like there's a change right here in between -3 and -1, or in between 0 and 1. I'll do 0 and 1 first. 0 and 0.5 actually. So I'm going to do second calc, but this time I think I see a min there. Let me try that again. So I see a min in between -1 and 0.5, so I'm going to select minimum, number 3. And I'm going to type in -1 for the left bound, and I'm going to type in 0.05 for the right bound, 0.5 for the right bound. Yep, I want my root in between, my min in between there and there. My minimum was at -0.141. So your other way to do this is look for maxes and mins. So notice I didn't actually use anything with derivative here. I just knew that horizontal tangents meant that there might be a change in direction. But the best way to find horizontal tangents, though, is going to be this way. This is the best way to find horizontal tangents. Okay, and I didn't really make this clear here, so I'm going to just put in an extra note here, use y equals with and derive. Okay, that's better. And that's everything here for this. The general skill that we went over here was using Math 8. So now I'm going to keep this all in one video. I know it's kind of lengthy, but I think it's all useful information. What I'm going to do is go to the next slide, and we're going to look at 3 types of AP problems that are just examples. I want it noted, the toughest part about AP calculator problems is that you need to translate what the question is asking into what do I need to do on my calculator for this problem. So the first one, the graph of y equals e tan x minus 2 crossing the x-axis at one point in the interval 0, 1. What is the slope of the graph at this point? Okay, so I want to know what is the slope of the graph at this point. So slope. So I'm just going to unpack this before I actually try to solve anything. Notice I am taking the time to find what calculus skill I need before applying a calculator to it. Slope, that's derivative. So I need a derivative at some point. At the point, okay, I don't know what point. So there's some x value here, but it crosses the x-axis at one point. Oh, in the interval 0 to 1. The 0 to 1 means my window needs to be restricted from 0 to 1. So x min needs to equal 0, x max needs to be equal to 1. I wouldn't actually write this all down on the test. I'm just writing this down to communicate to you. And I'm looking for a root. So crosses the x-axis means I need the root. And that root is equal to the x, which means that the slope, so I need y prime of the root. Okay, now I see how to do the problem. I'm going to go ahead and do this in about 30 seconds. I'm going to talk it through, but I'm going to do this on the calculator. Let me go to y equals. Let me clear this out. I'm going to keep y2 in there because I actually will want that eventually. I'm going to do e to the tan x minus 2, tan of x, and then minus 2. While I'm doing this, I want to bring up that there's so many students that try to solve this by hand. Horrible idea. Let me push on here because I don't really care about all this. I just care about the window 0 to 1. I could have still found this on the graph the way I was graphing it, but I just want a nice clear picture. Like that tells me my root. So let me find this root. Second trace, let's go and do a 0. And I'm going to go and do 0 to 1. 0, and then 1, for my right bound, guess it. Okay, I need to write that down, 0.6061119, 0.6061119. So my root is 0.60, oh my gosh, I forgot already. Yep, 06119. Okay. One thing that students will do is I've seen some students, and this just kills me every time I see this, is they do e to the tan of x minus 2. They set it equals 0, e to the tan of x equals 2, and they will then take the natural log of both sides, and they say tan of x equals ln of 2, and then they do tan inverse, and it's not wrong, guys. It's not wrong, but it's supposed to be a very quick problem. So because it's supposed to be a very quick problem, we do not want to take the time to solve x by hand. It's a calculator problem. Use the calculator. Okay, now let's go and do y prime of this. So I'm going to go and quit. I'm going to do math 8 and x. I'm going to do y alpha trace for y1. And I'm typing in that number, which was 0.606111. Enter. 2.96 is the answer. Let's see if that's one of the problems. Yes, it's D. Okay. That's my first AP question. Second one. If f prime is equal to that horrible looking function, then f has a local max at x equals. Now, you may not have done this in your class yet, but a local max is anywhere where f prime, the graph of f prime, I'll put that in first, the graph of f prime changes from positive values to negative values. F prime changes from positive to negative. Okay, so let's go and enter f prime in. I won't actually need the derivative here, but I'll keep that there just in case. We got second square root, we got x to the fourth. X to the fourth plus 1. Whoa, that's not what I want, Mr. Lakin. That is just a rookie move. Okay, x to the fourth plus 1. Then we need to do plus x cubed. And while I'm typing this, I just am thinking again of students I've had in the past that actually try to set this first derivative equal to 0. And I can't tell you how bad of an idea that is, because your efforts are going to be futile to try to solve that. All right, let's go ahead and do a graph root on this one. Keep in mind that this y1 is the first derivative. I had an old window here, so I'm going to do a zoom standard now. Oh, look at that. And I want to know where f has a local max. I need a change in root from a change in sign from positive to negative. These are positive values. Here are negative values. And it looks like there's only one change in sign right here in between 0 and 1, coincidentally. So let me go and do a root on this. So it's 0. Let's type in 0, and then 1, and then guess. Oh yeah, that's 0.35. Excellent. So that looks like it's going to be C. My answer is C here. And again, what I did is I did y equals, and then I did a root. For this one, for x in between exclusively negative 1.5 and 1.5, let f be a function with the first derivative of a horrible looking function. Which of the followings are all intervals in which the graph of f is concave down? Again, a concept we did not get to yet, but just to unpack this to see how I could use my calculator, I need to do one of two things. Either one, on the original function, on the derivative function, so see where f prime changes from, it's not, I'm sorry, hold on. I'm thinking of a couple things at once again, and I get confused when I do that. Let's try that again. See where f prime is decreasing, or graph the second derivative. So let y2 equal the second derivative, and then graph. And then I want to see where the second derivative is 0, is below 0. F double prime less than 0. Okay, so this is how I'm going to solve the problem. Let me go and enter my function. So I'm going to do y equals, let's see what I got here. I got e to the x, oh my gosh. Let's do Oh my gosh, I'm so sorry. I sneezed into that. That's just so awkward. Okay. X to the fourth. All right, minus, I promise I don't have coronavirus. Minus 2x squared. 2x squared plus 1. Yeah, minus 2. Okay, what I'm going to do is I'm going to deselect y1. So I'm going to deselect y1. I'm going to select y2 because I actually want to see the second derivative. And the second derivative is the derivative of the first derivative. And y1 is the first derivative because we have f prime. Okay, let's go into a graph. It's going to take a while. I'm going to do zoom standard just to reset the window. Oh, it's going to take, oh, wow, that's fast. Okay. Now, where is the graph concave down? Well, it looks like it's concave down in 2 places. It looks like the second derivative is negative here. And it looks like the second derivative is negative here. Okay, so I just need to get those values, or I could just look at my answers and see what they kind of recommend to me here. Yeah, it's a toss-up between C and D. Actually, it just looks like it's D. But let's get some values here. I'm going to do some roots. So let me see what the roots are here. Actually, I'll show you another cool trick. Let's do zoom box. When you do zoom box, it gives you the cursor. And what you can do with the cursor is you can move it around left, right, up, and down. But what you really want to do here, I'm going to go ahead and push the cursor to the top corner of a box here, top left corner box here, and then start moving this cursor left and right. I'm sorry, right and down. And then when I push enter, it's going to zoom in on that portion of the graph, which is all I really care about. Oh, that's for sure negative 1.5 to 0. Answer is D. Answer is D because that's where the graph of the second derivative is negative. Okay, guys, I hope this helped you on how to utilize the calculator in hopefully efficient ways. Thank you for watching, and please give feedback if you have any.